Open Simulink and start by double-clicking on the workspace. Type gain into the search bar and select the gain block. The gain block is used to multiply an input signal by a constant value. Next, double-click on the workspace again, type constant, and select the constant block. The constant block generates a constant signal that you can use as input for your model. Then, double-click again, type scope, and select the scope block. The scope block is used to visualize signals in your model, allowing you to observe how the output behaves over time. Place all the blocks wherever you need them on the screen, and then connect them together. Double-click on the scope block to open it and observe the graph. Run the model, and you'll see the output as a constant point on the graph since our input is a constant, and the gain is set to 1. Now, if you change the gain value or the constant value, you can observe how the output graph changes. Feel free to experiment with these values to learn from it. For example, if we change the gain value to 5 and run the model again, the output will reflect the new value, showing 5 on the graph. If you click on the constant block and look for the 3 dots that appear above it, you'll find several options. The first option allows you to comment out the block. Commenting out disables the block temporarily without deleting it, so it doesn't participate in the simulation. This is useful for testing or troubleshooting, as it lets you isolate specific parts of your model without losing their configuration. Now, disconnect the constant block by clicking on its connection line and dragging the connector away from the constant block. You can then comment out this block for later use. Next, double-click on the workspace, type sine, and select the sine wave block. Make sure to select the correct sine wave option, not any other similar block. The sine wave block generates a sinusoidal signal, which oscillates in a smooth, periodic manner. It is commonly used to represent waveforms in dynamic systems. Place the sine wave block in the model and connect it to the other blocks to observe how the sine wave affects the output. Now, to connect the sine wave to the scope, look next to the scope block and you'll see a small plus sign. Click on it, and a new input will appear. Connect this input to the sine wave block. Run the model, and you will be able to observe how the gain block affects the sine wave. The scope will display both the input sine wave and the output after it has passed through the gain operation, allowing you to compare them visually. Next, change the amplitude of the sine wave to 5 and run the model again. This will increase the peak value of the sine wave, making it oscillate between +5 and -5. You'll see how this change affects the output, allowing you to observe a larger range in the signal. After that, adjust the gain value to 10 and run the model again. With a gain of 10, the output sine wave will be scaled by a factor of 10, amplifying the input signal significantly. This means the sine wave will now oscillate between +50 and -50, showing a clear effect of the gain on the signal. Now, go back to the commented out constant block and uncomment it. Delete the constant block since it's no longer needed. Now, if you press the spacebar on your keyboard, the model will automatically adjust to fit within the screen. This is a simple model that anyone can easily create. Feel free to experiment by changing the values and exploring how these adjustments affect the model's behavior.